Well, g'day Year 7s once again. Alright, today we're looking at the area of parallelograms, okay? Now, what is a parallelogram? Well, it is, and follow the cursor, any four-sided shape where both sets of opposite sides are parallel to one another, okay? That means that if this line and this line were infinitely long, they went forever, they would never cross over, they would never touch each other, okay? That means they're parallel. It's really just a pushed over rectangle, okay? That's the easiest way to think of it. And another way to think about it is that a parallelogram is a rectangle in disguise, okay? Now what do I mean by that? Well, let's just imagine we let's imagine we get a pair of scissors and we cut that triangle right there, right off, okay? And it's coloured in pink here. And then we take that pink triangle, all right, and we put it in here. Now what would happen is it would fit perfectly, which must mean that the area of this parallelogram here is exactly the same as the area of this square here, because we haven't thrown any little pieces that we've cut off away, and we haven't gained any pieces. We've just chopped a bit off and stuck it on the other end. Now that is why the formula for the area of a parallelogram is basically the same thing as the formula for the area of a rectangle, except we don't say length times width, we say base times height, okay? And it's really, really easy. So we're going to jump straight into some practice questions, all right? So here we go. Question 1. Here we have I'm going to stuff this word a million times. Parallelogram. Feel free to laugh at me on YouTube. Here we have a parallelogram. It has I know that 8 centimeters is on the top, but we know that if that's 8 centimeters, this here must be 8 centimeters as well. So it has a base of 8 centimeters and it has a height of 5 centimeters. Now notice that the height is not the length of this side here. No. That's the most common mistake. Sometimes they'll give you 3 numbers. They'll give you the base, 8 centimeters, the height, 5 centimeters, and then this side length, which might be, 6.5 centimeters or something like that. And a really common mistake is that people will multiply the 8 by the 6.5. That's completely wrong. It's base, which is 8, times height, which is a vertical line, which is 5. Okay, so area equals 8 times 5, which equals 40, and our units are centimeters. So 40 centimeters squared. Don't forget the squared. Okay. Moving on to question 2. This one looks a little bit more confusing, but it's not. All you have to do is tilt your head to the left 90 degrees, or pick up your laptop and put it on its side, and then you will see that this 3 meters here is actually the base. Okay? And this 800 centimeters is the height. Now on this diagram here, the height was indicated on the inside, but I could have easily drawn the arrow on the outside here like I've done over here. You just have to get used to both ways of looking at it, okay? Problem here is that we have centimeters and meters. So 800 centimeters, that would make a lot more sense to convert that into meters rather than convert the 3 meters into centimeters. So that's the first thing I'm going to do. I'm going to convert 800 centimeters into meters. So here we go. 800 centimeters equals 800 divided by 100, whatever that gives you, meters. Okay? So 800 divided by 100, because there's 100 centimeters in 1 meter, gives you 8 meters. All right, so that's the height if we put our head on the side, okay? So now the area is not 800 times 3, it's 8 times 3, which is 24 meters squared. Okay? Pretty straightforward. And just to finish off, one slightly trickier one, another problem with a hole in it. Okay. Now these funny arrows, I haven't actually got them on the above diagrams. I probably should have done, but sometimes they're left off and you just assume that it's a parallelogram. So these two sides are parallel and these two sides are parallel. And the fact that there are two little arrows here on both sides and one arrow on these on this pair of sides, that means that this pair of sides have different lengths from this pair of sides. Okay, so it's not a pushed over square, it's a pushed over rectangle. Okay, and we have a hole in the middle which is a square because we have one line, one line, one line, one line, and they're all 1.5 centimeters. So it's 1.5 by 1.5 by 1.5 by 1.5. So that's a hole that's been cut out of a parallelogram. So if we want to find the area, what we need to do is imagine that this hole was never removed. We want to imagine that the whole thing is blue. So what would the area be in that case? Well, the area would simply be the base times the height. The base is 6, because it says so up the top here, and the height is 5, and the units are the same, so we do 6 times 5, and that would give us 30, right? And that's the area without this hole. But unfortunately we do have a hole, so we have to subtract the area of the piece that was cut out and thrown in the trash. So minus, and then we have to recognize what sort of shape this is. Well, it's a rectangle or a square. Remember, a square is just a special type of rectangle. And the area of a rectangle is length times width. And because this is a square, the length and the width are the same, 1.5. So the area of this piece that we're removing is 1.5 times 1.5. In other words, 1.5 squared. So the area of the complete parallelogram before that piece has been cut out is 6 times 5, which is 30. Then we have to minus 1.5 times 1.5. In other words, 1.5 squared, which gives us something a little bit less than 30. 27.75 centimeters, because we're dealing with centimeters, squared. And it's simple as that. Alright guys, thank you for tuning in. I will talk to you next time.